Okay, let's unpack this. We're diving into the surprising forecast for winter 2025-2026. Multiple models are suggesting what looks like an almost perfect storm scenario. It signals a pretty dramatic shift from recent patterns. So our mission today, cut through the noise, understand why this winter is projected to be so dynamic, especially for you out there tracking these global shifts.
Yeah, and what's really fascinating here, I think, is this unprecedented confluence of global atmospheric factors. We're not just talking about simple cold snaps. We seem to be looking at heightened volatility, a significant increase in extreme weather across the whole northern hemisphere.
Right. Before we really get into the forecast itself, let's maybe level set on the polar vortex. I mean, for those of us who follow this stuff, what's the key distinction people often miss? It's much more complex than just one big storm, isn't it?
Precisely. That's the critical thing. The polar vortex isn't just one thing. It's two distinct layers, really. And they're interconnected. You've got the stratospheric polar vortex way up high, maybe 5 to 30 miles up. It's usually pretty stable, forms in fall and winter. Then, closer down to us, there's the tropospheric vortex. That's the one directly messing with our day-to-day weather. But the really crucial concept for this winter seems to be coupling. How a disruption way up in that stratospheric vortex can actually descend. It comes down through the atmosphere to influence and, frankly, distort our surface weather.
Okay, coupling. And the jet stream must play a huge role in that downward path, right? It's like the gatekeeper for the polar vortex. If the vortex weakens, does that gatekeeper just let all the cold air spill out?
That's actually a great way to put it, yeah. The jet stream is that fast river of air, the boundary between the really cold polar air and the warmer mid-latitude air. So a strong, stable stratospheric vortex. It keeps the jet stream tight, flowing mostly west to east. That usually means milder winters for many. But when that vortex weakens high up, and that weakness couples downwards, it causes the jet stream to get really wavy, buckled, like a river breaking its banks. And that's what allows that frigid Arctic air to plunge way further south than usual, right into populated areas.
Okay, so we've got the vortex, the jet stream, the coupling. Now let's connect the dots. What's making winter 2025-2026 look so unusual? You mentioned this trinity of drivers creating a kind of perfect storm. What's the first big piece?
Absolutely. The first, and it's a very significant piece, is La Nina. The model show a really high probability will transition to a weak La Nina. We're talking, a 71% chance for October to December 2025. Those colder Pacific waters during La Nina, they generate these powerful planetary waves, Rossby waves, huge atmospheric ripples that shoot vertically up, and they directly hit and disrupt the stratospheric vortex. Historically, La Nina winters already have something like a 60-75% chance of triggering a sudden stratospheric warming event.
Wow, 60 to 75% chance just from La Nina. So we're starting with the deck already stacked for disruption in 2026. That really ramps up the potential, doesn't it? Even before adding anything else. What's the next driver?
It absolutely sets the stage.
Yeah.
The second driver is the quasi-biennial oscillation, the QBO. We're expecting a descending easterly phase. Now, you can sort of think of the QBO as an atmospheric waveguide. Depending on its direction, it either blocks or, and this is key for the coming winter in this easterly phase, it strengthens the upward path of those planetary waves. It basically makes the polar vortex much more vulnerable to collapsing under that wave pressure.
Okay, so La Nina sends the waves up, and the easterly QBO acts like a booster for Got it. And the final piece.
That would be Arctic sea ice extent, specifically the Barents-Sankhara Seas, the BKS region. Current data shows very low sea ice there. That's, it's a textbook situation for weakening the vortex.
Yeah.
But what's really powerful here is the synergy, the vortex weakening effect from that BKS ice loss. It gets much stronger when you combine it with an easterly QBO, because that easterly QBO is boosting the energy transport from below right when the low ice is trying to weaken it from the surface patterns. It's a double whammy.
Incredible how these different global things line up. So when does this combo La Nina, QBO, low sea ice actually turn into weather we feel down here? What's the trigger?
Well, they dramatically heighten the potential for a sudden stratospheric warming in SSW. This is a really rapid, dramatic temperature jump way up in the stratosphere. We're talking maybe 50 degrees Celsius, that's 90 Fahrenheit, in just a few days. It can completely disrupt, even split the stratospheric vortex. And that triggers the downward coupling we talked about. It takes maybe 1 to 10 days for that disruption signal to work its way down and really buckle the jet stream, changing our weather patterns fundamentally.
And when that jet stream buckles hard, what does that winter actually look like for us? Is it just cold everywhere?
No, not necessarily uniform cold. That's key. It usually leads to a winter of really pronounced contrasts and high volatility. Some regions will get slammed with extreme cold outbreaks, heavy snow potential. Others, though, could stay unusually mild. The central U.S., for example, looks like it could become a real winter battle zone. Think of it like a tug of war. One week, record cold. The next, maybe surprisingly mild, then bam, another cold snap. Very back and forth. High-impact events are more likely.
Okay, volatility. So what does this mean for you listening right now, for us preparing? Can we look back at past events like this?
Definitely. We can look at historical analogs. Think back to winter 2013-2014. That had vortex stretching, record cold in the eastern U.S. The Great Lakes hit over 90% ice coverage. Or maybe more recently, the February 2021 SSW. That drove frigid Arctic air all the way down to Texas. Caused widespread power grid failures, you might remember that. The signals we're seeing for 2025-2026, this combination of drivers, they strongly suggest an increased likelihood of a more extreme SSW event and those kinds of downstream impacts.
So the bottom line isn't bundle up for 6 months solid. It's more like prepare for unpredictability. Prepare for swings.
Exactly that. Prepare for volatility. And, this raises an important question. How can understanding these really complex global systems help us prepare better? On a large scale, we're talking about things like stress testing energy grids, reinforcing supply chains. And for individuals, well, it means thinking about home insulation, having emergency kits ready. These seem like prudent steps given the higher chance of extreme, potentially rapid onset weather events this setup suggests.
A really fascinating, maybe slightly sobering deep dive into what could be a truly dynamic winter ahead. So here's something to think about. How connected do you really feel to these huge global climate systems, knowing that a shift miles above our heads can ripple down and literally change the weather right outside your window? Something to consider. Stay informed and stay ready.